From this lecture, we will start clippers and clampers. These two topics are very important, and from this you will definitely have 1 or 2 questions in your exam. We use diodes along with resistors and capacitors to shape the waveforms. In the last few presentations, we have completed diode rectifier circuits, and in case of half-wave rectifier, if this is the input waveform, then the output waveform will look something like this. The negative half will be clipped, and in case of full wave rectifier, the output waveform will look something like this. So you can clearly see we have changed the shape of waveforms. In this case, this was the waveform, but by using the half wave rectifier, the waveform is now different. In the same way, we have different waveform by using the full wave rectifiers. So we can say that diodes along with resistors and capacitors can be used to shape the waveforms, and we call these circuits wave shaping circuits. So clippers and clampers are wave shaping circuits, and if we want to clip portion of the waveform, we use clippers, and if we want to shift or clamp the DC voltage level, we use clampers. Half wave rectifier is the simplest example of clipper circuit. We have clipped the negative half of the waveform. Clampers are used to shift or clamp the DC voltage level. For example, if this is the input voltage and we are using the clamper circuit, so the output waveform will look something like this. We have shifted the DC voltage level by using the clampers. In this lecture, I will explain clippers. Clippers are networks that use diodes to clip a portion of input signal without distorting the remaining part of the waveform. In case of half wave rectifier, negative half of the waveform is clipped and the remaining part is not changed. So there is no distortion of the remaining part of the waveform. Clippers are also used in noise reduction. For example, let's say this is the input signal. This is the input signal on the transmitter's end, and we have to transmit this signal by using any channel. On the receiver's end, we have distorted signal like this. The signal is distorted because of the noise, and we have to eliminate the effect of noise by using the clippers. So first we will clip this portion of the waveform, and then we will clip this portion of the waveform. After we are left with signal like this, and we can amplify this signal by using the amplifiers to have the original signal back. Once we amplify this signal, the magnitude will increase and we have the original signal back without any noise. The next thing is the classification of clippers. Clippers are classified into 2 types, series clippers and parallel clippers. In case of series clippers, diode is connected in series with the load resistance, and in case of parallel clippers, diode is connected in parallel with the load resistance. Series clippers are again classified into 2 types. First one is the unbiased series clippers, second one is the biased series clippers. Parallel clippers are also classified into 2 types. First one is unbiased parallel clippers, second one is biased parallel clippers. Unbiased clippers are also called as basic clippers. Unbiased clippers are also called as basic clippers, and in case of biased clippers, there is additional DC source present in the clipper circuit, and in case of unbiased clippers, there is no additional DC source present in the circuit. All these 4 types of clippers are again classified into 2 types. The first one is the positive clippers, second one is the negative clippers. Positive clippers and negative clippers. In case of positive clippers, positive portion of the waveform is clipped, and in case of negative clippers, negative portion of the waveform is clipped. For example, in case of half wave rectifier, you can see negative portion of the waveform is clipped, so this rectifier is negative clipper. This rectifier is negative clipper because negative portion of the waveform is clipped. Now we will move to one example to make things more concrete in your head. Example number 1. First I will make this circuit. In this circuit we have one diode, and I'm considering the ideal diode. We have to find out the output voltage, and the output voltage is measured across the load resistance. Let's say the output voltage is VO. The input waveform is like this. This is the input waveform VI. This is time axis T. V minus V, 0, T by 2, T, where T is the time period. First I will analyze this circuit for the positive half cycle. This will be the polarity, plus minus VI is the input voltage. We are considering the ideal diode. So as soon as the voltage, the input voltage is greater than 0, the diode will be reverse biased. So I will replace this diode with open circuit. I will replace this diode with open circuit, and you can see there is no current through this resistance R. So output voltage VO is simply equal to 0. This is what we have for the positive half cycle. Now we will analyze this circuit for the negative half cycle. From T by 2 to T, this will be the polarity, minus plus, and diode will be forward biased. So I will replace it with the short circuit. And you already know how to check whether the diode is forward biased or reverse biased. You have to match the direction of current with the direction of arrow in the diode symbol. The diode was connected like this. This is the arrow in the diode symbol, and in this case the direction of current will be like this. The direction of current will be like this. So the direction of current is matching with the direction of arrow in the diode symbol. So the diode is forward biased, and we have to replace it with the short circuit. I will use Kirchoff's voltage law to obtain the output voltage VO. Minus of VI plus of VO equal to 0. So simply VO is equal to VI, and VI is equal to minus V for the negative half cycle. So VO is equal to minus V. Now we have to plot the output waveform, and it is good to plot the output waveform just below the input waveform, but I'm not going to do this in this lecture because this is very basic circuit and there is no need to plot the output waveform just below the input waveform. But from the next lecture we will always plot the output waveform just below the input waveform, 0 to T by 2 to T VO. From 0 to T by 2, this means for the positive half cycle the output voltage is equal to 0. So we have 0 as the value of output voltage, and from T by 2 to T, which means the negative half cycle, the output voltage is equal to minus V. So the output voltage is equal to minus V. So this is how the output waveform will look. And now we have to find out what type of clipper it is. We have already completed the classification of clippers, and now we will try to find out the type of clipper that we have analyzed in this example. First thing is to find out whether it is series clipper or parallel clipper. Diode is connected in series with the load resistance. You can easily check whether it is connected in series with the load resistance or not. This load resistance and this diode are having the same current through them, so we can say that they are connected in series. So it is series clipper. It is series clipper. The next thing is to find out whether it is unbiased series clipper or biased series clipper. There is no external voltage source in this clipper circuit, so it is unbiased series clipper. It is unbiased series clipper. And the last thing is to find out whether it is positive clipper or negative clipper. You can see this positive portion is clipped in the output. So this is positive clipper, positive clipper. So finally we can say this circuit is positive unbiased series clipper. I was about to solve the second example also, but I think only one example is enough in this lecture. In the next lecture we will solve examples based on series clippers.